Hello, today we will talk about the distance formula. Before I cover the distance formula, however, let's talk about the distance on a number line. So first I want to find what is the distance of segment AB. So as a reminder about notation, when I write AB without the bar on top, that's talking about the length of the segment AB. So from A to B, how long is it? On a number line, that makes things easy. We can just go ahead and count. From A, I can count that I moved 1, 2, 3, 4, 5, 6, 7, 8 spaces. So the distance from A to B is 8. However, what if my numbers are super large, like I'm going from negative 52 to positive 139? Do you want to count that much? Because I wouldn't. So instead, what we can do is there is a sort of a formula, a method for it. So here's my next example. Going from C to D. Notice I'm going to the left. From C to D, how far is it? So this is a method that will always work even for large numbers. I want to go from C to D. Alright? The way you do this is you take the second number, x2, minus the first number, and then we're going to talk about what happens here. So my second number, x2, I'm starting at C, ending at D, so my second number is negative 6 minus my first number, 6. And again, that's still CD. So negative 6 minus 6, that will give you negative 12. And let's talk about that negative 12. We're talking about distances here, lengths. In context, does it make sense for me to say, from school, I'm gonna walk 6 miles down the road. Going back to school, I walk negative 6 miles. No one says negative 6 miles in real world context. So distances, your final answer may sometimes be negative, but if we're talking about the distance or the length, we're going to go ahead and say that we're referring to just the positive 12. So this tells me that from D to C, they are 12 units apart. Now let's go to the distance formula. There is a distance formula. What if we have right here a slanted line? On a graph, I can just count straight to the right and I can count straight up, but I cannot count diagonally. So one of the methods we have for that is the distance formula, expressed by D equals the square root of x sub 2 minus x1 squared plus y2 minus y1 squared. And I'm not going to spend a whole lot of time on where that formula comes from. All I'm going to say is this formula can be derived. It comes from the Pythagorean theorem. So there's my distance formula. Back to my example over here. Previously, I taught you the Pythagorean theorem. Using the Pythagorean theorem, we can just count that, okay, going to the right is 1, 2, 3, 4, 5, 6. Going up is 1, 2, 3, 4, 5, 6, 7, 8. So we can use the Pythagorean theorem of 6 squared plus 8 squared to find c squared, my missing side. And sometimes that works. But just like with the distance, where you may have numbers that are too big to count, you may see examples, points that have very large numbers. You're not going to want to count those large numbers. So instead, we can use a distance formula. Notice distance formula are using the x's and the y's. What that is referring to is the ordered pair. If I am going from A up to B, this is my first point. That means this is my first x and my first y, because ordered pairs go x comma y. And this is my second x and my second y. So now I can plug these numbers into my distance formula, which I'll work on here over to the left. D equals the square root of, notice that square root stays there the whole time, my second x, which is 7, minus my first x, which is 1, squared, plus my second y, which is 10, minus my first y, which is 2, squared. When I'm working the distance formula, I keep working on the inside of the square root. The square root is the last thing we want to take care of. 7 minus 1 inside the parentheses gets me 6, so this becomes 6 squared, plus 10 minus 2 is 8, so this becomes 8 squared. The square root is still there, we're not touching it until the very end. 6 squared, 6 times 6 gets me 36, plus 8 squared, 8 times 8 gets me 64. So ultimately I am taking the square root of 100, and the square root of 100 is 10. So there you have the distance formula in action. Over here, as a side by side, let me continue the Pythagorean theorem. A squared plus b squared equals c squared. 6 squared gets me 36, plus 8 squared, 64, equals c squared. Adding 36 and 64 gets me 100, equals c squared. Last step of a Pythagorean theorem, to get rid of the squared, we square root. And the square root of 100 is 10. So here's a side-by-side similarity. Notice, in my distance formula, I have 6 squared plus 8 squared. 6 squared plus 8 squared. 36 plus 64. 36 plus 64. We take the square root of 100. I took the square root of 100. So this is why the Pythagorean theorem and the distance formula are related. Really, the main difference, distance formula, you write that square root at the very start and keep working with it. But in Pythagorean theorem, the square root happens at the very end. Right? So, two key things that I showed right here is one, when I'm talking about the distance between two numbers, you subtract the second number, x2, minus the first number. For example, if I am looking for distance, how far apart from, and I'm just making numbers up here, 83 to negative 29. So I'm starting at 83, I'm ending at negative 29. So what I want to do is take my ending number, negative 29, minus my starting number, 83, and negative 29 minus 83, show that right here, gives me my negative 112. Because I'm talking about the distance, I don't say I drive negative 112 miles, I just drive 112 miles. So key things here is the distance between two numbers we subtract. And then, second part is the distance formula. Notice you see the same x2 minus x1 here. You find your distance in x, how far did you move to the left or the right, and then your distance in y, how far did you move up or down, and plug them in. So I move 6 units to the right, I move 8 units up, and continue with the formula. Last thing I'm going to show you is how to type the distance formula all in one line on the calculator. You can do that on the calculator. We start with the square root. Again, that's second x squared. And you type in the formula as you see it. I see moving from left to right, parentheses, 7 minus 1, close parentheses, squared, plus, open parentheses, 10 minus 2, close parentheses, squared. And that the calculator will give you that answer. So when you're typing the calculator, key things to watch out for are your parentheses and your negative signs. Please, please, please do not confuse a negative sign with a minus sign. If your equation ends up having something like minus a negative or plus a negative, I want you to actually still type them out. For example, if I say 5 minus negative 2, on your calculator, I want you to still type 5 minus negative 2. Keep the minus sign and the negative sign. Alright, so that's my last bit of advice for distance formula.